All right, so today we're looking at section 6.2. We're going to be revisiting all those formulas we talked about with the Delicious Dogs worksheet, and now we're going to actually be using them. So, big idea number one was when we added two random variables, like when we added the dog plus the bun, you can just add the two individual means. So, if you want the mean of two random variables added up, add the two means together. For variance, you can add the variances, but in order to get the standard deviation, you have to take the square root of the variances. And just remember, good algebra skills, this, you cannot cancel off the squares when you're adding. So this does not equal the standard deviation of x plus the standard deviation of y. You're not simply allowed to add the standard deviations. It just doesn't work that way. So you have to do the variance first and then take the square root of the variance. Just be very cautious of that. When you're subtracting two random variables, you can subtract their means, but we add the variances. That was that kind of weird thing that we figured out on the Delicious Dogs worksheet, that even when you're subtracting the two random variables, you still add the variances. And then again, to get the standard deviation, take the square root of whatever you got for the variance. The next idea was when we were multiplying by some constant. So for the mean, to get the mean, just literally multiply by that constant. Take the old mean and multiply by the constant. For the variance, you take the old variance, but now you're multiplying by the constant squared. For me, I just remember, look at all the squares. You got a squared here, a squared there, a squared there. You're squaring everything. For standard deviation, you would take the square root of this variance, but because you're multiplying, it actually does cancel off the squareds. So we can just take the old standard deviation and multiply it by that constant. Technically, it's the absolute value, but I don't think you ever really have to worry about that. And then this was the last idea. When you're adding or subtracting a constant, it will change the mean. You'll take the old mean and you'll add that constant on. But the standard deviation and the variance, those don't change. They stay the same. Okay, so we're actually going to use the formulas now. So I'm giving you random variable x and random variable y. And here's all the information for random variable x. Here's all the information for random variable y. For part A, I'm supposed to do 4 times x. So I have to find the new mean, the new variance, and the new standard deviation. So since I'm multiplying by a constant, if I want to find my new mean, the mean of 4x, I can just take my my original mean and multiply it by that constant 4. So I can take 4 times the mean of x. So that would be 4 times 12. And we get 48. Okay? For the variance of 4x, according to the formula, if you need to look at the formula, look at the formula. You take that constant and you square it and you multiply by the original variance. So I would take 4 squared, which is 16, and I would multiply it by the original variance, which was 9. And 16 times 9, we get 144. Now, to get the standard deviation of 4x, I'm just going to take my variance and take the square root of it. The variance was 144. I'm just going to square root 144, and I get 12 for my standard deviation. Hopefully you can see that this was squared up here because that's a variance. Okay. All right, moving on to part B. Now we're going to take the random variable y and we're going to add a constant to it. So you might want to look at your big idea number 4. Okay, I can take, when I want the mean of y plus 5, I can take the mean of y and just add 5 to it. So I can take the mean of y, which was 20, and add 5 to it, and I get 25. For the variance of y plus 5, this is a squared. It's a little hard, I'm writing on a weird little board. For the variance does not change. This will be the same as the variance of y. And the variance of y was 16. That stays the same. Standard deviation. Well, again, standard deviation, just take the square root of whatever the variance was, the square root of 16, and you get 4, which is what it was. It didn't change. Okay, next one. Now we're going to subtract 2 random variables. This is big idea number 2. So if I want to find the mean of x minus y, I can just subtract the 2 original means. I can take the mean of x minus the mean of y. The mean of x was 12 minus the mean of y, which was 20. And I'm going to get negative 8. For the variance of x minus y, okay, remember this was that kind of crazy rule, a little counterintuitive maybe. You're going to take the variance of x, but you're going to add the variance of y. So the variance of x was 9 plus the variance of y is 16. So we get 25. And then to get the standard deviation of x minus y, we just take the variance and square root it. So the square root of 25, we get 5. And then down here for D, we're going to, it's like a combo of multiplying, like in part A, and adding 2 random variables. So this is like a combination of big idea number 1, where you're adding, and big idea number 3, when you're multiplying by a constant. So to get the mean of 2x plus 3y, I'm going to take 2 times the mean of x plus 3 times the mean of y. So that will be 2 times the mean of x was 12 plus 3 times the mean of y, which was 20. And for that, we end up getting 84. For the variance of 2x plus 3y, when you are multiplying by a constant, you do the constant squared times the variance of x. And again, when we're adding random variables, we add the variances, so plus. And then this constant 3 needs to get squared times the variance of y. So that's going to be 4 times the variance of x, which was 9, plus 9, because that's 3 squared, times the variance of y, which was 16. So 4 times 9 plus 9 times 16, we get 180. And then lastly, for the standard deviation, standard deviation's always nice and easy. You just take the square root of whatever you got for the variance. So we're going to do the square root of 180. And you get 13.42. Okay, so a lot of it is using your formulas. It's all formula work. I'm going to highlight all these answers that we got. So we got 48, 144, 12. We got 25, 16, and 4. Over here we got -8, 25, and 5. And then we got 84, 180, and 13.42, just so you can see them a little bit better. Okay, moving on. All right, for this problem, we are given a probability distribution. This is Anna's playing skee ball. This is a probability distribution of Anna's score on a single roll. Okay, so we're supposed to find the mean and the standard deviation. Okay, so this is going back to section 6.1. How do we find the mean of this? Remember, it's that expected value. So the mean of A, you can get it by doing 10 times 0.32 plus 20 times 0.27 plus 30 times 0.19 plus so on. Or we could use our calculator to make this go a little bit faster. So we are going to type all those values in. So it was 10, 20, 30, 40, 50. And then we have to type in the probabilities, 0.32, 0.27, 0.19, 0.15, and 0.07. And we got to give it a title. So this is A for Anna and her probability, PA. Okay, so I'm going to go home, go to the calculator. We're going to do menu, statistics, stat calculations, one variable stats. Keep it at one list. The X1 list is A. We have to change the frequency list to the probability, so PA. Hit OK. All right, so our average is 23.8, and our standard deviation right here is 12.63. All right, so I'm going to write those down. Now remember, the bare minimum is you have to write the formula. Okay, so the formula for the expected value, or the average, is sigma xi pi. And again, for the average, it said 23.8. For the standard deviation, again, we have to write out the formula. So it's the square root sigma parentheses xi minus mu x, all that squared, times pi. All of that's under the square root. And again, the calculator told us that the standard deviation was 12.63. Okay. Now, it says, what's the mean number of tickets she expects to earn per roll if a ticket is given for every 10 points? Okay, and these were points up here. This was on a score, so that's dealing with her points. So this would be the expected number of points. Okay, now she's going to get a ticket for every 10 points. So we are trying to find the mean number of tickets. So she gets one ticket for every 10 points. Okay, so think about, what are we going to be doing to the points? We're going to be taking the amount of points, dividing them by 10, and that's how we get how many tickets. Maybe we'll do it off to the side. Tickets would equal the number of points divided by 10. Okay, so what that means is if I'm going to find the new mean, I'm taking the A value and I'm dividing it by 10, which we could think of that as the same thing as 1/10 times A. So realize we're multiplying by a constant. So this is applying big idea number 3. Okay, we're multiplying by a constant. I think on your sheet it's 3b, big idea 3b. So we can take that constant and multiply it by the original mean. So we're going to do 1/10 times the original mean, which was 23.8. And we're going to get 2.38. So that would be the expected number of tickets. 23.8 is her expected number of points. If she gets a ticket for every 10 points, then we would expect her to get about 2.38 tickets. Hopefully that makes sense. As far as the standard deviation goes, okay, the rule for big idea number 3, when you're multiplying by a constant, you can just take that constant and multiply it by the standard deviation, the original standard deviation. So we're going to take 1/10 and we're going to multiply it by the original standard deviation, which was 12.63. So we're going to get 1.263. Okay, so again, if you're having trouble with these formulas, take out the Delicious Dog worksheet, look at the back, because that's all the formulas we're following. Okay, or you could rewind this video because we reviewed them at the beginning of the video. Okay, moving on. Now, all that stuff was about Anna. Okay, now that was a single roll. Here's just a recap of what we found, the mean and the standard deviation for Anna's single roll. Now we're going to talk about a game, which consists of 5 separate and independent rolls. Okay, now we want the mean and the standard deviation for the total number of points she gets for a game. So we want the mean number of points for a game and the standard deviation for a game. And a game consists of 5 rolls. And this was the information for single rolls. Now, what you have to figure out is, are we multiplying by 5 or are we adding 5 of these together? Because those are 2 different things. Okay? Hang on just a second. I'm gonna pause this video and then I'm gonna make another one.